Hi guys, welcome back to Environmental Geography. We are in week 3, right, of our semester. We're going to be going over chapter 3 today. And again, the first few weeks we're really just getting the idea of the environment started, right? Last week was just a really quick introduction to the idea and discipline of environmental science. And today we're going to be looking at ecosystems and energy. Later this semester, we are going to be talking about this more in depth. So I would say it's still kind of just like a brief intro to this. What is ecology? Ecology is the study of systems that include interactions among organisms and between organisms and their abiotic environment. What does abiotic mean? Well, if you're looking at the slide, yeah, abiotic means non-living, right? Biotic part of the environment would be plants, animals, anything that is living, right? And then when we talk about abiotic, that would be non-living. So ecology literally means the study of your own house. And we can look at the environment as our own home, right? It was coined by Ernest Haeckel or Haeckel. It's a Greek word for the study of your own home. So what today will entail is different levels of organization. We're going to get from the individual species to the biosphere. And as geographers, what we do is we find patterns or similarities in things and we just organize them in different levels, right? Like you take the United States and you break it down into 50 states, or you take California, you can break it down into different regions, right? Northern, central, southern, inland empire. So that's what you do in geography. So what we're going to do is we're going to look at levels of organization, and this will come up later on this semester, okay? So what you're looking at here is what ecologists like to do. They're most interested in these different levels of the biologic environment, right? Organization that include or are at the level, right? So you go from the individual to the biosphere. And so we're going to take some time and go through that. Remember, the biosphere is the living part. So when we look at the Earth and we break it down into different spheres, you have the hydrosphere, cryosphere, biosphere, atmosphere, lithosphere, right? Biosphere is all living things. So let's start with the individual species, okay? At the very end, we're going to get to the biosphere. Now we're going to start with the individual species, okay? A species is a group of similar organisms whose members breed freely with each other, with one another in the wild to produce offspring. Okay, that's pretty easy. An individual is just a species, right? Like a penguin. Now that penguin or that giraffe or the caterpillar belongs to a population of penguins. One individual species belongs to a population. A population is a group of organisms of the same species. So this picture here shows you a population of penguins, right? Or the giraffe example, or whatever example it is. Okay, they must be the same species that live in the same area at the same time. So we're going into a higher level of organization. Now these populations are organized into communities. Now here we start to introduce different species, okay? Communities are associations that consist of all the populations of different species. I think my mic is off. Hopefully that's better. That's probably better. So communities consist of all the populations of different species that live and interact within an area at the same time. So now you can have, this would be like not a real example, but the penguins interacting with the caterpillars, right? They're part of a community. But a better example is this picture here of a coral reef. right? That's a great example of a community. Because most of the time, when I ask for examples, people tend to think terrestrial or community examples on land, but you know, our aquatic ecosystems are just as important. And a coral reef community is a great example of where you have different types of populations of species with living around each other, right, within a coral reef community. So right now, our coral reefs are in danger because our oceans are becoming more acidic. There is more CO2 in the atmosphere than ever before. CO2 is naturally occurring, but it is also because of our addiction, our high use of fossil fuels. So now there is more CO2 than ever before, and our oceans are really feeling that impact. Instead of being balanced, you know, water is on this pH level or this pH scale, right? Being neutral, highly acidic or alkaline, it is moving towards a more acidic um, side of the scale. And, you know, our oceans becoming acidic is one of the problems. We also have sea surface temperatures getting warmer. So there's a lot of things going on in the ocean, and it's really affecting our coral reef communities. We have lost 50% of all our coral reefs within the last 30 years, and that data is from 5 years ago. So it can be even more than that now. We are seeing our coral reefs bleaching. The bleaching of our coral reefs is kind of like they turn white. Some of them recover, some of them come back, and some of them don't. So coral reefs are not only important because they're a beautiful part of this entire planet, but they're important because they serve as this hub for a lot of things going on in the ocean, right? Like these ecosystem communities. I had the pleasure of going to a coral reef about 3 years ago. I went to the second largest coral reef, which is in Mexico on the Yucatan Peninsula. It is in Cancun, the Mesoamerican Great Barrier Reef. The first one is in Australia, that's the largest barrier reef. The second one is in Mexico. So coral reef communities, they have the greatest number of species. They are the most complex. Today, many reefs are threatened by climate change, and climate change is directly caused by too many fossil fuels or too many greenhouse gases, too many variable gases in the atmosphere, which cause more warming. Here is the reef that I visited. That was a picture of me. I was super excited. I had never been snorkeling before in my life, so that was a huge event for me. These are pictures that I took. We were in the Riviera Maya, all along the coast over here in this peninsula. So if you've been to Cancun, you could have been closer to the zona hotelera, where most of the hotels are. I think I said it correctly, hotel zone, or Quintana Roo, or you can be closer to the Riviera Maya. And so it's a very large area. There's a lot of different places in Cancun that you could have stayed at. But where we stayed, I stayed there specifically because I wanted to be able to go snorkeling within that barrier reef. It is home to more than 65 species of stony coral. I mean, you guys can read this slide here. But it has been directly affected by climate change. When I went snorkeling there, it was December of 2017. Yeah, December of 2017. There's a lot of things. And again, it was my first time, so to me, anything would have been amazing. But I did see schools of fish. I saw jellyfish. I saw trumpet fish. Saw stingray. So it was pretty amazing. We went back the next year in 2018, a little further south, and I was able to swim with turtles, with sea turtles, which was really amazing too. And the guys that took us out on these little ships, these little boats, I asked if they have seen any coral reef become bleached, and they said, yeah, a few years ago that there was a lot of reefs, a lot of coral that were bleached, and some of them came back and some of them didn't. All right, moving up in that level of organization, and those levels of organization is the ecosystem. So we look at the individual species. The species is part of a population. That population lives within and belongs to a community. And that community is found within an ecosystem. Now there's many there's many communities within one ecosystem, right? Does that make sense? So an ecosystem encompasses the totality of interactions between organisms, among organisms, and between organisms and the non-living portion of the environment. So you're looking at how species interact like with plants, right? And soil and the sun and water. So you're looking at both living and non-living, biotic and abiotic interactions, right? How communities interact with that and how communities live within communities or next to communities, right? So within that ecosystem, there's many communities. And within those communities, there's different populations of species. Does that make sense? And within those populations, there's obviously different species, right? And so now going higher into that, I think I have one more slide on ecosystems. Yeah, I don't. Okay, so going higher in that, those ecosystems belong to the biosphere. Okay, so I think that was it for levels of organization. Yeah, so we're still looking at the discipline of ecology, very related to environmental science, to environmental geography, right? But a sub-discipline would be landscape ecology, who you're looking at ecological processes operating over large areas. You think of a landscape consisting of a forest ecosystem located next to a pond ecosystem, and you're looking for connections between those ecosystems. Does that make sense? One connection between the two ecosystems might be blue herons that fly from the pond ecosystem into the forest ecosystem and eat, I don't know, frogs from forests. Or like there's these interactions between separate ecosystems, right? That would be landscape ecology. Landscapes then are based on larger land areas that include several ecosystems. One important term to know, okay, I think I'm reading notes further on. One important term to note is your ecosystem services. So if you guys enrolled in this class, I can probably assume that you guys know that it's important to protect ecosystems, right? That our Earth is important to protect and it's vital to learn about this planet and learn about the environment. And I know that you guys know much more than maybe a student who isn't interested in this, right? Because this is kind of like a special course that you would register for, right? But you know, it's obviously you and we know that protecting ecosystems is important because it's our duty to protect them, right? But how can we express that to the person who may not really care about the environment as much, right? How can we say like, hey, these ecosystems are important to protect? Why, right? Not the normal, but the average person would want to see how ecosystems benefit us. So what I'm trying to get to is ecosystem services. We have 4 different types of services that ecosystems provide to us, okay? Ecosystem services, they are any positive benefit that wildlife or ecosystems provide to people. So what is one benefit that an ecosystem can provide to you? That's what I would probably be asking you in the classroom. And then some of you would say, oh, biodiversity, great, lots of different types of animals. Some of you would probably say, I don't know, shade, that's a great answer. Some of you would probably say clean water, yes, that's also a great answer. But these are all benefits for us, right? And unfortunately, we live in a place and a time where if you can't attach like a monetary value or individual um, like what does it benefit me? That's the way we can assure that people are going to care about something. Because that's the way humans think, you know? Like, how can we present this in a way that you're going to care about it now? So moving forward when it comes to things like public policy, if we present this ecosystem, say like there's a park down the street from your house, and there's a lake there. okay? And Walmart's going to come in and tear it down and build a huge warehouse there, a huge store there. If you present this park with a lake, this area of land with a lake, to your city council and say, hey, if we keep it as a lake and keep all these trees here, in the long run, you're going to be saving money because there's going to be less asthma. Air is going to be cleaner. It's going to be more purified. There's going to be less CO2 in the atmosphere. Later on, we're going to save more money in, I don't know, we're going to save more money, right? Does that make sense? Once you start to attach like a monetary value to an ecosystem, then people will start to say, hey, maybe we should protect this area. Maybe this landscape is important. Because unfortunately, that's how things work when we look at public policy. And when we look at human nature, that's just how it is. How does it benefit you? And, you know, we live in a very narcissistic society. It's all about personal gain, right? Like, what good does it do me? But, you know, if we start to attach these benefits and services that ecosystems provide, that's a good thing because now we can say, hey, it's important to save these wild spaces because they bring in money in the future. You have all these tourists coming and ecotourism is important. This water is going to be clearer or cleaner, sorry. This air is going to be more purified. We're going to have more fish in this river. Do you guys see the point that I'm trying to drive home? So there's different types of categories for ecosystem services, supporting, provisioning, regulating, and cultural. Go ahead and write this down. I hope you guys are taking notes of everything, but make sure you have these different types of services and their categories down, okay? And then on your module, you will have a really cool video that Mexico put out and how they're using ecosystem services in public policy and really attaching value to these places, to these ecosystems. It's pretty cool. Okay, so environmental spheres and Earth's realms. Again, you take, as a geographer, you're taking this large amount of data, whatever that data is, and you're finding similarities, right? Here, we're breaking down the Earth into different realms or different spheres. You have the lithosphere, which is all your inorganic portion, soil, mountains, rocks, minerals, things like that, land, right? You have the atmosphere. Atmosphere is all those gases that surround the planet, right? That's part of the atmosphere. Biosphere is the living and the not, sorry, just the living portion of the planet. So plants, animals, you and me, and fungi and bacteria, anything that is living would be part of the biosphere, right? The hydrosphere would be the oceans, and the cryosphere would be the frozen part, glaciers, permafrost, icebergs, snowpack, anything that is frozen would be considered part of the cryosphere. Here's a picture that gives you those 5 different spheres. These 5 spheres are not separate entities, but they are interconnected. They serve to broadly organize concepts of the systematic study of Earth's geography. And going forward, probably in the class, I would start using these terms: biosphere, atmosphere, cryosphere, hydrosphere. And I think you guys would know what I'm talking about. Okay, let's go on to the second portion of the lecture. This would probably be another day if we were meeting in the classroom. And again, when we are meeting virtually, things just are shortened a little bit when it comes to lectures. It's much quicker. So when we look at energy, we're going to be talking about energy and how important it is, right? We know that energy, every living thing on Earth needs energy to move, reproduce, grow, right? Starting from plants and algae in the ocean all the way to the largest mammal on Earth, right? Everything needs energy. And when we look at energy in this class, we're going to be looking at energy as energy from the sun. But there's several different forms of energy, right? There's chemical energy, radiant energy, energy from the sun, thermal energy, mechanical, nuclear, electrical energy. So there's several different forms of energy. And when we look at energy, it's important that you understand that energy cannot be created nor destroyed. So which leads us to the first law of thermodynamics, which you probably have learned if you took a different science class. Energy cannot be created nor destroyed. Organisms must absorb energy from its surroundings, but the total energy content of an organism and its surroundings is always the same. So energy from the sun comes in, right? Warms the planet, warms the earth, the sand, the grass, the water, all that energy that comes to the surface of the earth. Some of it is just re-radiated away back into outer space, but most of it is absorbed by the earth and then reflected back out into outer space. None of it is like, it doesn't disappear, right? It just is either turned into a smaller form of energy or just re-radiated back out into space. Okay, so energy cannot be created nor destroyed. Second law of thermodynamics is when energy is converted from one form to another, some of it is degraded into heat, a less usable form. So that's the second law. But what I'm trying to drive home is that energy can never be created nor destroyed. The amount of energy present in the universe during its formation is the same amount of energy present today, right? And that's just this very simple. I'm not like a physics or a chemistry teacher, so this would not like be something that I'm too well versed on, but it is important to know these two laws of thermodynamics. So why is that important? It's because we're talking about energy from the sun. It's really the building block for these ecosystems. And we're moving into how energy is converted, or how the sun is converted into energy, right? For these ecosystems to thrive. So energy from the sun is converted into food, right? So the base of these ecosystems would be plants, right? So photosynthesis, I'm sure you guys have learned this before, talked about in other classes, the process in which light energy from the sun is captured and transformed into chemical energy of carbohydrates, sugar molecules. So now energy from the sun is turned into a different type of energy, right? Now animal can come, eat this plant, and then that animal could be eaten by another animal. And so now what we're getting to is the movement of energy in this linear direction, right? This energy flow. So the flow of energy through ecosystems. They enter ecosystems as energy from the sun. Energy is stored. An animal eats that plant. Then another animal eats that animal. So this movement of energy, again, is called energy flow. It is the linear, actually I have a definition for you there. Not. Oh yes, energy flow. For this area here, guys, go ahead and pause it and write down the definition, which is the passage of energy in a one-way direction through an ecosystem would be energy flow. The passage of energy in a one-way direction through an ecosystem would be energy flow. The passage of energy in a one-way direction through an ecosystem is energy flow. So let's look at the different levels that that energy goes through, the path of energy, right? Who eats whom in these ecosystems? First you have your producers. So your producers would be your plants. They're really the only ones that can make their own food, okay? Or they're also known as autotrophs, self-feeders, or plants. Then you have your secondary consumer, which is going to eat that producer, or a heterotroph, sorry. Plant-eating animals are called also herbivores. Then you have your secondary consumers, which are also predators. Now there's many levels. It can go tertiary all the way up, and then it gets a little more complex because then you'll have these large predators and then these medium predators who can kind of make this more of a web rather than a food chain, if that makes sense, right? It, in the beginning, yes, it's just a plant is eaten by an animal that only eats plants. But then after that, it gets more complex. And then at the very end, you have decomposers. They break down the dead organic material, and then they return that energy into the dirt and everything. It's like the circle of life, right? The path of energy flow, who eats whom in ecosystems. So a very simple way of looking at it is a food chain. It's the unending flow of energy, water, and nutrients through the biosphere, through direct passage from one organism to another. So not only are we going to look at energy, but there's a lot of things that move through this system, right? Nutrients, water, all these things move through the system. Nitrogen, phosphorus, carbon. There's like a cycle for everything, okay? And that's more for chapter 5. We're going to look at those cycles, these biogeochemical cycles specifically. But today we're just looking at more of a food chain, but you'll see that things in life in this world are not like specifically linear. It's more of a food web. So a food web is a better way of looking at it because you have this system of interlocking and interdependent food chains, right? That's a better way of looking at things. It's a more realistic model of flow of energy and materials through an ecosystem. So for example, this food web here, yes, the sun, and then you have your plants that take energy from the sun and create their own food, right? They here through photosynthesis, right? Then you have your primary consumer. They're only going to be eating plants. But then when you get to your secondary and tertiary, it looks like more like a food web because a dingo can eat a jackrabbit and maybe can eat a red fox, or I don't know what this is. This is a chaparral food web from Australia. But you get the idea. Things are more interlocking here rather than just producer to primary, secondary, tertiary consumer. Does that make sense? So this is a chaparral food web, and later on you will learn specifically about the biome of the chaparral biome, which is the biome that we live in here. We're part of the chaparral biome here in Southern California, and it does occur in 5 other places on Earth. The Mediterranean climate zone fosters this type of vegetation, but here is a chaparral food web for the Australian chaparral. Food pyramid is another way of looking at it. You have here the consumer at the top of the pyramid is the largest or most powerful predator, and if you share the same level, like say this owl and there's a fox here, just pretend, I'm just thinking off the top of my head, they can share the same level in this pyramid. You would call that a trophic level when they consume the same types of food in the pyramid. So like these guys here, they share the same trophic level because they're all plant eaters. Does that make sense? So now when you start to look at these food pyramids, what would happen, say, there was a disease that wiped out all these primary consumers. They all died, all of them. What would happen to the plants, the first level? It would overpopulate, right? Because nobody's eating this level here. So this would grow crazy. What would happen to this level here? They would die too, right? They would drop in numbers. Why? Because their prey has disappeared. So these levels don't operate, separately. They're very much related. So if one trophic level disappears, it has a drastic effect on the entire food pyramid. Okay? And so another name for that is called the trophic cascade. So one trophic level being affected, there is an effect on the entire pyramid. And specifically, the trophic cascade is when the predator is affected. So what do you guys think would happen? Like, of any ecosystem, of a forest, of the ocean, of the rainforest, of the chaparral, any ecosystem, top predator is completely out. What would happen? Would it be good? Would you think it would be all good, a good effect, sorry? Or would it be negative? Or nothing would happen? Like the bottom ones would just be the next predator. So see, I wish I had more interaction with you guys. And this would be a point for discussion. So trophic cascade is when the apex predator is removed or the top predator of the ecosystem is removed, and there is cascading effects on the entire pyramid. There is a link to a very cool video about wolves in Yellowstone, and you'll have a discussion about it. Yeah, the trophic cascade phenomenon. It's either if you add or remove top predators, there's a cascading effect on the entire food pyramid. Like for example, one would think if you were to add more wolves into an ecosystem, there would be less animals, or there would be negative effects, or not good, right? But after watching the video, you will see the addition of top predators brings these ecosystems back to life, and I'm driving home the point that everything is interconnected and everything has a piece in this puzzle, right? Or has this note in this beautiful symphony. So that video will really drive that point home, and it's actually a very beautiful video. Trophic cascade scenario, you remove the top carnivore. So this is before, and the top carnivore is there. Cool, you have ducks, you have all these bluebirds, diverse plant community. And then if you remove that top carnivore, that top predator, there is a huge change in the ecosystem. And that video will show you how even removing or introducing a new predator, the top predator, will have changes in the actual physical geography of an area. So the addition of those wolves at Yellowstone Park, I'm kind of going to spoil it for you guys, changed the meandering of the rivers and the whole entire physical geography of Yellowstone Park. Just by adding a family of wolves that actually should belong there. And so that video will cover that. Pollutants in the food chain, just like nutrients, energy, water, and other things are moving along this chain or this flow, unfortunately, so do pollutants. And now plastics, for example, are so prevalent and pervasive in our world. You have plastics that are broken down so tiny and found in the ocean that they have made their way into the actual plankton. Microplastics are found in zooplankton, which are so tiny, right? So what does that mean? That means at the very top of these oceanic food webs or food chains, that plastic will be found there. So that means that, yes, there is plastic in sea salt. There is traces of plastic or bisphenol A or polymers in our fish, in our sea salt, because the ocean is so polluted with these microplastics. And I'm not talking about these large pieces. When this water bottle is left out in the sun, floats out into the ocean, because everything goes into the ocean, UV radiation interacts with the plastic, it photodegrades it, and it kind of like shards it down into these very tiny, tiny pieces. Now you have to think years and years and years and years and years floating in the ocean, and those tiny pieces turn into tinier pieces. So that's what these microplastics are. Plastic is a very, very genius invention, but it also has been something that we rely on so much, right? And it's so pervasive in our society, in the entire world. I mean, it's in our clothing, it's in almost anything, it's in our beauty products. So plastic is extremely pervasive, and it's not like you can just eradicate it. Every molecule of plastic that has ever been created is still here. So we'll talk about that more. But what I'm trying to talk about, what I'm trying to get to is this idea of biomagnification. The higher up the food chain this pollutant or toxin or plastic goes, for example, its bio magnified or biomagnified. So, for example, a DDT concentration in the water might be at 0.000003 parts per million, but once it moves up, right, goes into zooplankton, goes into small fish, goes into large fish, and then this bird of prey, it's biomagnified. The concentration is larger. Pollutants in the food chain, same idea. These microplastics, evidence has shown that some chemical pollutants can become concentrated within a food chain. This is a process referred to as biomagnification. Adding to that, because we'd probably be discussing microplastics in the ocean, something that is also important is, hopefully I can stop this today, is our use of microbeads. Microbeads are found in a lot of exfoliants, and we think that, oh, well, it's scrubbing our face, and a long time ago I probably thought the same thing, but these microbeads are flushed down or run down the drain, and our water processing systems are not built to filter out these very tiny beads. So where do they go? They go straight into the ocean. So it's not just like litter and plastic. How embarrassing. I'm your environmental teacher, and I have a plastic water bottle at home. It's not like I'm on campus, but I went to my mom's house, and I love mineral water, and this is all she has. This is embarrassing. What I'm trying to say is, like, you know, as conscious as we can be, it's still in our lives, right? Just like totally thinking about my lifestyle right now. I feel terrible. But what I'm trying to say is that these microbeads run down the drain, and as you're going, they're picking up all these toxins, and they are just like these little sponges of toxic chemicals that are found in our drains, and then they drain out into the ocean. And then what eats that? You know, it moves up the food chain, and then who does it go to? Us, right? We do such a good job of eating clean, organic, trying to buy, you know, the best ingredients to put into our body. And, you know, a lot of times it's like in our oceans, and there's things that we cannot control. But it starts with us, right? With our choices as consumers. So if you do want to still exfoliate, and you should exfoliate, it's really good for you, buy things that are natural exfoliants. So you'll know it's a natural exfoliant because, one, it'll say not to use it every day, and two, it'll probably say something like walnut shells, sugar scrub. Read the ingredients. If your ingredients on what you're washing your face with say poly anything, P-O-L-Y, it is probably derived from plastic, okay? So, or make your own, right? There's a lot of things you could do. So, still exfoliate, people. Still good for you. Microplastics, same thing here. I think I kind of drove that idea home. You will have some links and some things to look at that on your module. Mercury in fish is another example of biomagnification. It is not naturally occurring. These toxins bioaccumulate, or they are biomagnified within fish. So what I mean by naturally occurring, it doesn't mean that they're naturally occurring in the fish, but they can be naturally occurring because of volcanoes or certain areas that these fish are found around. Industrial activity as well helps, adds to that mercury in the oceans or lakes. There are high levels found in lakes and oceans, and they do affect us physically, our nervous system, birth defects, and we just know it's not good for you, right? I think that's it today, guys. And that was a pretty quick lecture. You will have a journal this week, and then I think that's it. This is not going to be your journal, though. It'll be a different. Maybe it won't be. Actually, this might be your journal, but without this part. Yeah. All right. you guys, don't worry about this journal. Just worry about what is on your module, okay? So sometimes I just kind of have to work with these lectures that are supposed to be for in class, but I hope you guys are enjoying my lectures. Take care. Email me with any questions, and thanks for being patient, you guys. Take care.